Okay, so let's go ahead and look at one of the die. So which one do you guys want to look at, so in case we run out of time? Do you want to do the 6, 8?
Percentile dice.
The what?
Percentile dice.
Which would be which one?
The two 10-sided dice.
Well, let's go ahead. Let's look at just a single one, though.
20.
So you want to look at the 20? Does everybody want to do the 20? Okay, that's the biggest one. So let's go ahead and we'll look at the 20. So I have that on your sheet. And we said, what did we say? So like for your sample space, what would you put for your sample space? What do you think would be your sample space for a 20-sided die?
1 through 20.
Okay. Now, could you just put the 1-20?
No.
No. And why could you not do that?
Because we're only doing the integers, the positive integers.
Awesome. Yep. So you're only doing the integers. So kind of what Sarah's referring to is if you were to do 1-20, you're saying that, say, 10.5 is an option when it's not. So you actually you'd have to actually on the sample space, you'd have to write out 1, 2, 3, 4, all the way through 20 with a comma in between each one. Our theoretical probability, we said, was 5%, right? So go ahead and try rolling it 60 times and then putting your frequency down on this sheet. So that's why I gave you the sheet. So go ahead and try it 60 times and see if anybody gets exactly 3, which should be the theoretical probability.
And a side note with probability and can something happen the same way? I always think it's fascinating with lottery, people that win the lottery. And there's some people I watch these TV shows and they have won the lottery more than one time. And I think it is a hard feat to win the lottery in the first place because the experimental probability of it or the theoretical probability of it is so low in the first place. But if you think about it, it doesn't mean that if you win the lottery the first time, it decreases your chances of winning it the second time, because it's not like your name gets taken out of a pool or something. But it still always baffles me that some people are that lucky, because I think at that point it does have a lot to do with luck, that some people can win it more than one time. It doesn't, and it always seems to hit the people that don't need it as much.
That's true. And what's funny is I think I saw an article one time of a guy that he actually was up in New York. He was helping during a natural disaster, wasn't even from the state, and won the Kansas lottery. So, but they actually say that theoretically you have a better chance of getting struck by lightning. I don't know if anybody's, there's a better chance of getting struck by lightning than winning the lottery.
Yep, I believe it.
Surprisingly, I'm pretty across the board. 10 is my most prevalent now. I've had 3 of those. But 1 through 11, I've gotten at least once. And that's pretty unlikely with as few rolls as I've done. 1's been pretty popular too.
While you guys are rolling this, something that maybe Brian can talk just what the setup of this problem is, but my favorite thing to always do in my Provenance Stats when I was teaching Provenance Stats a little bit more was something called the Monty Hall problem, and it's based on like a game show that used to be on, and it might still, they might have redone it now. It still might be on the Game Show Network, but the Monty Hall I want to call it the Monty Hall, or the Monty Python problem. It's not. It's the Monty Hall problem, because it was based on a game show where the contestants had 3 doors they could pick behind, and they wouldn't know which one the actual prize was. The other 2 would have kind of, I used to play it. It was like 2 doors would have a goat, and like 1 would have a car behind it, and you had to choose door 1, 2, or 3. And then if you chose Monty Hall, the guy in charge would show one of the doors that had a goat, because for sure there was one that still had a goat behind it. And then he would let you choose if you want to change your option of door that you pick, or do you want to stick with the one that you originally chose. And there is a difference, or your probability is actually, it does change, or will it stay the same? And that's the question. Should you stick, or should you switch your options? And so if you get a chance after we're done here, I would maybe Google it, see maybe if you're not understanding exactly how to do the problem. But what I would actually have students do is run an experiment then with it too. If you don't believe it, your gut tells you something, and theoretically and experimentally it turns out something different. So it's kind of an interesting problem.
So Garrick, did you have something? I think you're gonna say something.
All 60 rolls.
So did you get every number at least once?
Yes.
I finally, on my 47th roll, I finally got every number at least once. What was your highest frequency?
I think I got 8 6 times, and 14 and 15 5 times each, and 18, 13, and 3 4 times each.
Oh, really?
Mm-hmm.
My biggest one so far has been 3. I've gotten that, let's see, was it 1, 2, 3, 4, 5, 6 times? Yep. So I've gotten 3 6 times, so. I've got 10 more rolls. Yeah, because with me, my numbers were more dominant from 0 or 1 to 10, which is kind of interesting. Anybody have questions on the die?
Hey, what did I miss? I'm so sorry. I'm on
You're fine.
babysitting, so I was trying to help her with some stuff.
Oh, not a problem. So Jesse, we picked one of the dice, and in there you should have a 20-sided one.
20-sided.
Yep. So now what we're doing is we're rolling that. So
Is this it?
yep. So we're rolling that basically 60 times, and we're trying to see if we get, so our theoretical probability for that is 5%.
Just
theoretically,
we're probably not gonna wait for you to finish all 60 rolls, but you might want to when they start a new set here in a second, you might want to just stop the 20-sided one and start up with them fresh on the new one.
yeah, it's probably about, I was thinking
Yeah.
about 2 or 3 minutes, and then we go to the 6-sided die. So that way we have the smaller sides.
These dice spin really well.
Yeah, I was kind of surprised. I didn't know. I've never used a 20-sided die, so
I have.
I figured that if you were into those type of games, because it's neat to see the way that they're shaped. So some of you are kind of finishing up. What I found interesting was the way that the 8 and the 10-sided die, or the 10-sided and 8-sided. So to me, the 10-sided kind of reminds me of like a diamond, because you have the two that are kind of, it's pointy on the tops, and then you have your 5 numbers. Now what's interesting, if some of you are done, what would be the sample space of the 10-sided die? Because that one's kind of interesting in this, what a lot of people probably don't know. What is the sample space of the 10-sided die?
10.
It's not 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
0 through 9.
Yeah, 0 through 9. So a lot of people, if you were to ask them how many sides it has, a lot of people would say 9 because they'd see the 9 as the highest number. So like the reason I bring that up is one of the things that we talk about for a garage. So how many of you have a garage opener that you have to type in the numbers? Okay. And when you type in the numbers, like for the one that we have, it's 0 through 9. So a lot of people don't really recognize that you have 9. So let me I'm going to share another screen with you. Let me see if I get there it is. While people are finishing up, I was just going to bring up one thing. Okay, so hopefully you can see like a whiteboard here. So this is how I lecture with my my classes. So when we're talking about a garage door, we have, I'm just going to put 0 through 9, even though it's not correct. That gives me basically 10 numbers, right? So this is what you look at when you go on farther with probability. So if you're typing in, because let's say it's only 4 numbers, like my garage code is only 4 numbers. A lot of people are always worried about getting hacked as far as like people going in and figuring out your code. Let's figure what the probability is of getting the right code as people are finishing this up. What is the probability that you pick the correct first number? What would be the probability?
1 in 10.
1 out of 10, right? Well, then when you're doing multiple pushes, you're going to multiply. So now what would be the probability of getting the second number if you can duplicate?
100.
No, it'd still be 1 out of 10. So you still have the same. Now, to get 2 in a row, Isaac, it would be at 1 out of 100. So then the third number would be the same, 1 out of 10 and 1 out of 10. So on a garage door, for them to get the exact code, there's a 1 in 10,000 chance that they pick your code. So really, there's a pretty low probability that somebody can actually figure out the code for your garage door. There's 10,000 different possibilities. Okay. So what do you guys think about that? You think that's a little higher than what you were maybe thinking when you look at 10 numbers? Yay, nay, A-okay? No? You thought there'd be quite a few, Isaac?
I thought there'd be more.
You thought there'd be more? Well, how
Yeah, lower.
do you have a garage door opener, Isaac?
No.
No. Because I was going to say some have 6. You have to. It's a 6 numbered code. So then now you're talking about 1 in a million. If you add 2 more numbers. So like a lot of you that have phones, when you have the codes in your phones, you have 1 in a million chance of somebody picking your code. All right, let me go ahead. I'm going to go back to my chart. And let's go ahead and let's go to the 6-sided die. So Jesse, this will hopefully give you a little chance to do what we were doing earlier with the 20. So yep, just the regular 6-sided die, which looks strange in that bag because it's the only normal one to most of us. So now my sample space then is what? So what is my sample space for that?
One, two, three, four, five, six.
Yep, 1, 2, 3, 4, 5, 6. So now what is my theoretical probability? What's that, Sarah?
1 out of 6.
1 out of 6, which would be what is a decimal or a percent? What do you think? What would it be as a decimal or percent?
What number?
So 1 out of 6, any number, because remember it's equally likely. So if it's 1 out of 6, what would it be as a percentage?
16%.
Close, 16.7 or 17% if you rounded it. So one of the things that we talk about in probability is for the theoretical probability of the 20-sided die, you can say 5%. You can use the percentage because if you add them up, you get 1. But if you were talking about theoretical probability of a die, you would actually want to use the fraction because that's the only exact value you could have. So 0.167 is not an exact probability. You'd have to use a fraction. So when some of your math teachers say that you have to use fractions, that's why they say it, because they want an exact value. Okay, so that's why if you have Kelly as a teacher and she tells you use fractions, probably because she wants the exact value and not a rounded value.
That is very true. That is exactly what I tell my students, and especially if you're using something like pi or e, these numbers that you'll talk about eventually, then the less you round, the more accurate you'll be, and yeah, it's, anything that doesn't have a ending decimal point, I always want left as a fraction for the exact answer. Yep.
Yep, or they call it a terminating decimal. So if it doesn't have a terminating decimal, so like when you do trig, a lot of times you keep your answers with radicals. And the reason why is because they're exact. So with this one, again, since we're doing 18 rolls, you should get 3 of each one. So hopefully you won't have a 6, frequency of 6 in this one. So go ahead and roll your die 18 times, and let's see how close to the theoretical we get. So go ahead and roll your 6-sided die 18 times.
do we type in what we get?
You can, yep. What I would do is then for the experimental probability, I would probably do that then. So again, this is more of you won't turn it in, but I would definitely keep this as a resource for when you go into, say, high school, because this will kind of give you an example of what maybe a teacher's talking about when they start talking about probability.
Gotcha.
I must not know how to roll because I've got a lot of 4s already.
On the 18th one, I finally got one of all of them at least.
Really, that's pretty unusual.
I got 6 6s, 4 1s, 4 4s.
My 3s and 4s are mine most likely. Yeah. $17. I did one more roll. Oh, I got that one. So I got at least 2 on every one. Did anybody get 0 on any of yours? Like Garrick was saying, he finally got a 1 on every one on his last roll.
I got a 0 on 2.
0 on 2? On 4? So the reason I bring this up, again, this one has a better probability. So you would think, as I was actually, when I look at my 20-sided die, I still had one that had a 6 there, but it seemed like it was a little more across the board as far as like with this. But again, a different experiment could be different. So that's why they call it experimental probability as opposed to theoretical probability. Now, one of the reasons I bring this up is I like to watch sports, and in the Super Bowl, they were actually flipping a coin, to see who gets the ball first.
Oh, did you know that the EA sports video game company predicts who wins the NFL and how much they get with ridiculously close accuracy?
Really?
Yes.
I didn't know that.
It's pretty ridiculous, and they do better than people in Vegas.
You know what's funny though is they've also had a dog that they'll have like 2 bowls of food, and they've been more accurate than people in Vegas too. So who's to say? But yeah, they were flipping a coin, and they kept tally of heads and tails. As far heads, it should go 50-50. Well, there's 2 different divisions, AFC, NFC, and they actually found it to where for the AFC and NFC, it should be 50-50, but they actually, I think it was the NFC won it 10 years in a row. So that's pretty much an unlikely outcome. That's basically what you're looking at. Okay. So, since we only have about 3 more minutes left, I want to kind of get a little feedback from you guys. Any questions on it? Did you like the activity? Did it make sense? Any feedback from you guys? Has it been a good week as far as activities? Have you liked it? I heard you got to do a solar powered car. Did you like that?
Yeah, they actually made the windmill part of it, but they can deconstruct the windmill and create, like, there's 6 different solar powered little machines that they can make. The dog, I put together the dog, well, my daughter did, and she I didn't realize when I was telling you guys yesterday, the dog doesn't actually walk. I was thinking it walked, but it the tail on it wags. So I'll post the video for that. But yeah, I thank you very much, Brian. And I'm gonna post a video actually in the, I'll post it right now so you guys can see it on the Canvas site on today's thing that has, later on today it'll have the video recording of what we just talked about with Brian. And I apologize, I didn't start recording until a little bit into it, but we got most of it. We got all the dice activity. But also I'm gonna put in there the link to a video on that Monty Hall problem that I was talking about. And if you guys get a chance before we meet back up at 10:15 to watch it, I'm curious to see if you guys, what you think of it, because it just defies what your gut reaction tells you. I don't know about you, Brian, but it always did for me. Even though my gut reaction always told me that can't be true, and then I've done the experiment with my classes and it's worked out.
Yeah.
And so it's kind of a cool thing. If you're interested, you can figure out a way to experiment with it pretty easily. And so if you have somebody that kind of helps you work with just figuring out, like, just pick like 3 different cards and you can run an experiment yourself. But I'll post that video. You'll be able to check that here just in a couple of minutes. And so if you want to look at that over the next half hour, you don't have to by any means, but if you want to. But does anybody have any last questions for Brian? We give him a thank you for his time, and
All right,
you very much.
guys.
We appreciate it. And hopefully they'll see you in a few years and they'll
I
be
hope
taking
so.
classes from you.
Yep, I'd love to see you guys in class again. And actually, I've had a couple. This is my 3rd or 4th year in STEM camp, and I've had a couple I've seen out in public, or that have. I think I have one that took my class even. So, yep,
Cool.
I hope to see
Well,
you
make
guys.
sure that if you do take his class, that you tell him, in a
Yep.
few years, hey, by the way, I was on that virtual STEM class. 'Cause this is he'll remember for sure being on this.
Oh, yeah.
virtual.
My wife always laughs because I still remember high school students from 2006 from Manhattan High. So,
Yep. All right, cool.
All right,
Thanks, Brian.
have fun with my wife. She'll be doing the Pringles challenge with you guys later.
All right, sounds good. We will. We'll.
Challenge.
Garrick, what was that?
What's the Pringles challenge?
Well, we'll find out.